Hello and welcome to today's web seminar, How Google Tests Software, featuring James Whitaker, Software Engineering Director at Google. This is the first event of a series of web seminars where IBM will bring various thought leaders and to share their insights on new and emerging processes and solutions to deal with the complexity of testing today's applications. Now, before we begin, I'd like to explain how to participate in today's presentation. First off, if you have any technical difficulties, you may press the Help button on your player console. This will direct you to best resolving common issues. Or send us a note through the question field, and we'll be on hand to help as quickly as possible. Our private responses can be read in the Answer field. Clicking on Enlarge Slides will open a new window in which the size of the slides increases. Click Download Slides to open, print, or save a copy of the slides, which you'll see today. And if you'd like to tell your friends and colleagues about this event, click on Share Presentation to email your friends a link to this event. Now, we welcome your questions during today's event, so feel free to ask as many as you'd like by typing it in the question field and then clicking the Submit button. We'll attempt to answer as many questions possible during the Q&A session after the presentation. Also, I'd like to inform you that you'll receive an email in the next day or so that contains a link to today's archived presentation. And at this time, I would like to introduce today's speaker, James.
Thank you, Francesca. My name is James Whitaker. I am going to dispense with any other intro because we don't have that much time today. What you're getting is 45 minutes plus questions of a 4-hour seminar that I have been giving at various conferences. So let's get started. How Google Tests Software is a collaboration between me and two co-authors that work with me at Google, Jason Arbon and Jeff Carolla. It's a book. The book is coming out soon. I know because I just submitted the very final edits today. It's a blog at googletesting.blogspot.com. And for many of us at Google, it's a way of life. If you're interested in more information, you can follow me on Google+ or Twitter and be updated with what's going on here. So let's start. This is going to be a bit of a tour through the full tutorial and through the book. I'm going to try to get most of the salient points, and then I'll be around for questions at the end. Google is very much an engineering culture. It's not a culture that promotes a lot of management career paths. It's a culture that promotes individual contributors and engineers. We have fun things like 20% time, where engineers can do whatever they want for 20% of their time, a day a week. And this is where a lot of very interesting ideas come up and are developed. Gmail started as a 20% project. Chrome started as a 20% project, and now these are very popular applications on the web and on the desktop. So the other thing I want to mention here is project mobility. We get things done quick enough at Google that we ship software fast, and people are always moving around group to group. And so we end up with a lot of very general purpose employees, people who can code on the web, people who can code on the desktop, people who can code in the data center and back-end, front-end, test, dev, etc. So you get people who can move around quickly from project to project. The Google testing philosophy is that testing is not about quality. Testing is part of the engineering culture. Testing is part of development. Testing is part of what we do to ship software. Testing is not what we do to make software high quality. Quality starts with developers. Quality starts with project managers. Quality starts with testers. We're all in this together. What we do, I think, at Google is different, is that we make testing absolutely unavoidable. Developers can't check in code without certain automated tests being written. Developers can't check in code without code reviews occurring automatically as part of the workflow. Now, what we do with this is we have a couple of roles we're going to talk about today, the SET, the test engineer, and the test engineering manager. But we don't see ourselves as testers. We see ourselves as engineering productivity. In fact, that is what our group is called at Google, the group that is run by Pat Copeland. The idea isn't to do testing. The idea is to do development faster. And it turns out that the major cause of slow development is bug debt and quality debt. And I think if we've done one thing at Google with our secret sauce, is that we prevent an amassing of bug debt. And because of that, because our testing prevents the amassing of bug debt, we can move a lot faster. We developed Google Plus in 100 days. And over the summer, we produced 100 new features of Google Plus in 90 days. This is just absolutely amazing speed of development, and we've done that with as good a quality, industry class quality, first world class quality. Software is never perfect. Our software is not perfect, but we get it out quick and we iterate quickly. So the idea is to accelerate Google, not necessarily to do tests. So within engineering productivity, we have tools teams, central tools teams for the entire company. We do release engineering. We do engineering education. It's all about making developers better, making testers better, making engineering better. We have 3 roles of testers: SWEs, SETs, and TEs. SWEs are developers, feature developers. They do code reviews, they do TDD, they do unit tests, they do acceptance tests, and they own quality for every piece of the software that they touch. This is important. Testers don't own quality. You don't write a bunch of code as a SWE and give it to a tester and say, okay, make it better. Right? That's your responsibility. The SET, the second role, is there to help. SETs develop test infrastructure. Now, note here that they don't really write test cases. They write test infrastructure. In Google, the test feature is a feature that is equivalent to any other feature that ships to users. And an SET writes that feature, but it's the developers that write the test cases. The SETs are there as enablers. We will write the test infrastructure that the developers will use to test the feature that they're writing. I'm going to give a little more detail into that, and this whole concept is explained at some length in the book. Now, both the SET and the SWE are very much 100% coding roles. They write a lot of code. They review a lot of code. The TE, the third test engineering role that we have, is all about the user. The SWEs and the SETs are really their main work product is the actual code base that ships. They are beholden to the source code. Test engineers are not. Test engineers are beholden to the user. And we separate this for many reasons that are explained in the book, but the main reason is that the differentiation in the mindset of I'm here to serve the code or I'm here to serve the user is different. And we want people focusing on the code. We want people focusing on the user, and it's very difficult to do both. So this is sort of the reason we have this third class of engineers. This is not a manual tester. Test engineers at Google do a lot of coding, but they write scenarios. They generally write scripts as opposed to native code, and they generally write code that submits input, processes output, etc., as opposed to more unit-level type code. So here's how the roles overlap. We have these concepts of small, medium, and large tests, which I'll explain in a few minutes. But all of these roles overlap a great deal. Now, one of the most important parts of our strategy for releasing software, for releasing high-quality software, is this crawl, walk, run strategy that we talk about. The idea of building a product, getting it out, getting feedback, and then iterating quickly. Google is very good at doing this. We call this the minimum viable product or the minimum useful product. What we don't want is a 2-year development cycle. Some engineer has this great idea, this world-changing idea, and we just build it. It's just going to be awesome, and everybody's going to love it. Right? That sort of attitude doesn't work at Google. The attitude is, all right, you got a good idea, code up the core of it that's the most useful to the biggest number of people, and get it out there and see if you're right. And if you're right, users will come, and now you have an opportunity to iterate. Now, we do this even on products that are very large and very well established. Like if you look at Chrome, which is a product I spent 18 months of my life as a test director for at Google, Chrome builds daily. And we call this the canary build. And everyone associated with the product can pick up the canary build and check out the new features and see if they're high quality. If they're not, we just throw that build away and wait until the next day to build another one. Right? The best canary build of of the week becomes a developer build, which is the weekly build. Now, at Google, every single developer, every single tester, every single product manager, everyone associated with the product has to pick up the developer build every week and use it, right? You don't want a process where you have half your team using one build, the new build, half the team using an older version of the build, and then variations of that. You want everybody testing on the same build, everybody using the same build, so that if a bug is found, it's not because you were working on an old build of the software and that it's fixed in the new version. It's crucially important to get every project stakeholder working on the same build all the time. Now, the best weekly build of the month is called the test build, and that goes to dog food automatically, right? So we will push the new version of Chrome on a monthly basis to every internal user at Google, and we get lots of testing that way. At the end of this talk, I'm going to go through some of the tools that we have that allow us to collect really valuable feedback from our dog food users about testing, because we find out really that the dog food users find more bugs than our testers. They find more bugs than our developers. These are internal Googlers using our pre-release software, finding bugs and reporting them, and they are very rich bug reports. I'm going to talk about that later because this is really important. Instead of hiring a bunch of testers to act like users, we give our software to real users. They happen to be internal Google employees, and have them test the software for us. And in order to get by with doing that, we have to have a really rich set of tools. I'm going to show you those tools later. And then finally, the best test build becomes a beta, and it gets pushed out to early adopters, trusted testers, crowdsourced testers, etc. We're big believers in crowdsourced testing. In fact, I think Chrome is the project at Google, the product at Google that uses crowdsourcing the most. Now, we have three types of tests, mainly small, medium, and large tests. We don't call them unit tests, integration tests, and system tests. We do it for a reason. We do it for a couple of reasons. Number one, we have a centralized test execution infrastructure, and if you tell that infrastructure this is a small test, it knows that it's going to execute very quickly, and it can schedule it appropriately. If you tell it it's a medium test, it knows it takes longer time to run, so it can schedule it appropriately. At Google, we have a centralized test execution infrastructure that all of our projects use, and it schedules all the tests from all the different projects, and they run continuously 24 hours a day, 7 days a week. And so it's important to know how long each test is going to take so that the scheduler can optimize test execution. We don't want to get to the point where we have to say, okay, we only have 4 hours. Which test are we going to run? Our schedulers are smart enough to figure out that they can squeeze small tests in here and there and here and there, and we actually run every single test constantly at Google. So small tests are the domain of SWEs. SWEs really write all the small tests. I don't like my SETs writing any small tests at all. Small tests are tests written on a single unit of code, a single function of code that's written by a single person. And they test things like array out of bounds, loop plus one, a use of a single resource, right? These are very small tests. They're always automated, and they run really in microseconds. And they test, does this code do what it is supposed to do? Medium tests cover multiple modules, multiple functions, often written by multiple developers. And whenever you get to the point where you're testing 2 or more developers' code, you really need a third party to test it, and that's where the SETs come in. The SETs do write a lot of our medium tests because they're not the most – whenever you have a small test, the person that wrote the code is by far the most qualified person to write the test. Whenever you have more than one developer involved, none of them by default are the most qualified to write the test. And if you select one of them to write the test, they're probably going to write tests biased toward their own module. And so whenever we have these interacting modules, SETs write tests for that because they can kind of come above all of this stuff and really take an independent view of these tests. Medium tests are also always automated, and they run either in a real or a faked environment. Our small tests always run in a faked environment. If a module, if a unit of code calls a database, it won't call the real database. We'll write a mock or we'll write a fake that will return just the values of that database that we want. So small tests don't touch real resources. Medium tests can or can't touch real resources, although in my experience at Google, most medium tests also run in a faked environment as well. And by the way, in the book, this idea of mocks and fakes, we have real examples in real code of how to do that, how to write those, and how to manage code that really is written exclusively for tests and is not going to ship. And so the idea here is that we're writing tests to figure out if a set of nearest neighbor functions that actually call each other and interact with each other, do what they're supposed to do. The third type of tests are large tests. Large tests are generally written by test engineers and SETs, mostly test engineers. And this is the first point at which the test will run exclusively in the actual production environment and not with mocks and fakes. And this is the first time that tests are written that consume real user input. So instead of writing a test to test that a certain value passes between two modules, we're writing a test where a user enters this value and then the test will check that the right answer is produced. So these are user-oriented scripted tests. They can be manual, they can be exploratory, they can be automatic. Automation is preferred. In fact, the idea at Google is always automate it. If the results can be checked by a machine, automate it. If there's no human judgment or cleverness required, automate it. If you have to do it more than once, automate it. If it's too important that it can't be left to chance, automate it. And if it fails all of these checks, then we will allow you to do some manual testing. But if you can't automate it, please do. And even with the manual tests that we do, at the end of this presentation I'm going to show you what I think is world-class industry-leading recording technology where we will record in JavaScript the manual tests that are happening and be able to reuse them later. Now, again, a warning, I'm just going to take a breath here because I've been talking fast. I do want to get through as much of this as I can and point you to more resources that you can get the fuller picture. Shared code. This is a part of the secret sauce of Google's success in software quality. Not just anybody can check code into the Google infrastructure. You have to have a certain status to be able to do that. A new employee will have to go through a process we call a readability, where they will write code, check it in, but that check-in will fail because they don't have a readability, and that the code that they write will automatically hit our workflow system and be farmed out to people who do have readabilities in those languages. We have readabilities in C++, Java, Python, and JavaScript at Google. Those are the 4 languages that we pretty much use exclusively. And it's not until you have proven that you can code over time consistently without breaking the build that you get your own readability, and then you can be part of the review process as well. So no code gets checked into our code repositories, our source repositories, until these sorts of things happen. Platform dependencies are another part of our non-testing regime of making software better. All of our developer machines are the same operating system as all of our tester machines, which are the same operating system as all of our test lab machines, same operating system of all of our production and corp machines. We all use the same version of Linux. Whatever's in the data center is running on our desktops. So we never get the situation of, hey, I found a bug, and then take it over to the developer's machine to repro it, and all of a sudden the repro doesn't work, right? That doesn't happen at Google, and you shouldn't let it happen where you are either. And so the ability to identify dependencies, whether it's on the machine, the operating system, the libraries, or even the type of code that you're writing, right? If you're writing a web app, use HTML5. If you don't, you're introducing a whole set of bugs that you really don't have to deal with, right? So this is an important part of our strategy. And then another thing I want to mention before I get into some more interesting stuff is this idea at Google we have called Test Certified. We've kind of copied the CMM, the 5 levels of maturity in test, and we have a team at Google that goes around and judges development team's ability to produce high-quality software, and we have levels. In the book, we have actually interviewed the people who created this Test Certified ladder program, and that do all of the test certifications, and they talk about how they created it, why these levels are what they are, and how they do their assessments, and how developers have taken this. But we have groups from level 1 to level 5 throughout Google. So we do judge, testers do pass judgment on developers. Now, the 3 roles, SWE, SET, and TE, the one I want to highlight in this particular version of this tutorial is the test engineering role. And the test engineering role is, I like to call SWEs feature developers, SETs test developers, and TEs user developers, because TEs are developers. It is an artifact of the Google culture that we are a coding culture, we are a computer science culture, and coding is an important part of being judged by your peers, being admired by your peers, and getting promoted and getting good calibration scores. And our TEs do write a lot of code. I think from the TEs that report to me, both now and in the past, code anywhere from 20 to 80% of the time. TEs who code more than that generally get converted to SETs. SETs who tend to write lots of features as opposed to test features tend to get converted to SWEs. SWEs also convert to SETs, and SETs also convert to TEs. So this is a two-way street here. But it's the TEs that I'm going to be talking about for the remainder of this talk. If you want to hear about SWEs and SETs, you'll have to wait until the book comes out. So here's how some of this test engineering stuff that I'm going to talk about started. When I first joined Google, I spent a lot of time reading test plans, and all the test plans were different. The Chrome team's test plan was different than the Gmail team's test plan, which was different than the Android team's test plans, and it was fairly annoying. They had one thing in common. They were basically all out of date. They were written, reviewed, and then ignored. They were left to rot on some server somewhere. At least, trees weren't being killed for these test plans. But test planning is something that is part of the TE's experience, and we need to do it better. So what I did is I put a few of my engineers in a room, pointed at them at an app, and said, build the test plan for it. You got 10 minutes. And of course, I come back in 10 minutes, and they said, dude, we didn't think you were really serious because you can't build a test plan in 10 minutes. And I said, yes, you can. Try harder. Here's a different application. Write a test plan for it in 10 minutes. Close the door. Come back. And of course, then they're waiting for me, right? They knew I was coming back at that point. And remember, these people report to me, so they generally have to do what I'm told. And even though it's Google and engineers are in charge and not managers, there's still a general level of respect there. And so at this time, they had made a little more progress. They had written a few more things down. But 10 minutes was all I was going to give them. So I, again, changed the problem, left them in the room, told them they had 10 minutes, came back in 10 minutes, and I kept doing this over and over and over again. We did this for about an hour and a half until finally this team of engineers came up with something that they couldn't do it in 10 minutes, but they could do it in 30. So it takes 30 minutes to do a 10-minute test plan at Google. But here's what they came up with, because this has been a test planning method and a test engineering method that is not only becoming more and more widely adopted within Google, but there are open source tools now to pull it off. So in 10 minutes, you can't write a lot of stuff down. You have to be succinct. You have to be brief. You can't have a lot of prose. You can't do a lot of selling. You can't have much fluff. And it's got everything you put in the test plan has to be actionable. And so here's what we ended up with. The 10-minute test plan is something we call ACC, Attributes, Component, Capabilities. It's a simple and powerful model for thinking through what needs to be tested and how you're going to test it. It can be done in a matter of 30 minutes for any application at Google. Less than 30 minutes. Our record, the worst it's taken, the longest it's taken us to do this is about 24 minutes. And the least amount of time it's taken us is about 14 minutes. So this is something that can be done quickly. In fact, it takes longer to talk about it than it does to actually do it. So the attributes are the first thing. These are the adjectives and adverbs that describe your product. So examples from Chrome are Chrome is fast, it's secure, it's stable, it's elegant, blah, 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 right? These are basically if you hear someone, a salesperson or a product manager describe your product, write down every adverb and adjective that comes out of their mouth and you pretty much have these. They're easy to discover. Most of the time the adjectives and adverbs are on project pages. So if you look at the Chrome web page, home page, you can find all the adverbs and adjectives that are on the Chrome home page, and that basically becomes your attributes for the system. Generally, the attributes are 12 or less for any particular piece of software, and we've done this for a wide range of products at Google, and I think 18 has been the highest number of attributes we've ever had, and we probably should have pared that down a little bit. So coming up with the attributes literally takes minutes. The next step is components. Now, the attributes are the adverbs and adjectives that describe the system. The components are the nouns that make up the system. These are actually the parts of the products that we're going to test. So for Chrome, it's the URL bar, it's tabs, it's the web store, it's WebKit, right? These are the things that basically, if you want to understand the components, walk around, ask every single dev on the product, what feature are you working on, and they will name the component for you. This is also something that just takes minutes to do. And you get finished pretty quickly, and you move on to capabilities. So we have attributes, which are the adjectives and adverbs. We have components, which are the nouns, and the capabilities are the verbs, what the product does. So for Chrome, it loads web pages, it plays Flash files, it syncs preferences, right? It runs web applications, it executes JavaScript. These are all the verbs that you could, if you listed all the verbs that describe what Chrome does, you'd basically have the sum total of what needs to be tested within Chrome. And so you write all of these things down. Now this is the one that's more time consuming, but we have a little trick that we use at Google to get developers to do this for us. The last thing you want to do to a developer is ask them to help you. Right? The last thing you want to do is say, hey, we've got this ACC thing we're building and we've got the attributes, we've got the components, we need your help with writing down capabilities. They're going to tell you no. They're not interested in helping you. Right? That's what you're there for in their eyes. And so we have this little trick. When we did Chrome Operating System ACC, we sat down for about 20 minutes and wrote down every single capability that we knew that Chrome OS did. And then we took it to the developers. It happened to be like 304. We took it to the developers and said, hey, guess what, guys? Chrome Operating System turns out it's pretty simple. It only does 304 things, and that's all we have to test, right? We're totally psyched. This is actually kind of easy, only 304 things. This is great. And immediately the developers were annoyed, right? No way, right? This is our product. This is way too important. It's way too complicated. Developers always think their stuff is complicated, always. Doesn't matter how simple it is. The developers convince themselves it's the most complicated piece of software ever to be written, and there must be the smartest software developer ever to grace the planet. And when you go to them and tell them something actually quite simple, they want to prove you wrong. So if we would have asked them, how many capabilities, will you help us come up with them? They would have ignored us. Instead, we told them how many we thought they were, and they scheduled a meeting to prove us wrong. We got the same thing we were going to get anyhow, right? That's what we wanted. We just wanted their help. So we got it. They scheduled a 2-hour meeting, which at Google, wow, a 2-hour meeting is like trying to take somebody out for a week. No one goes to 2-hour meetings at Google. The default calendar entry for Gmail internally at Google is 25 minutes. So this is how important they took it. And sure enough, they sat down, reviewed all 304, and they proved us wrong. They found some 314, 320, something like that. They added a few, and we had a far more complete picture. So my point is, do a half-assed job of this and then sucker your developers into helping you, or just do a half-assed job of it and then start testing. You're going to discover all the capabilities that you missed as you start. That's why this doesn't have to take more than 30 minutes. So let me show you a tool now that we have developed at Google and open sourced. And you can find it on the Google testing blog. So here's how this works. You start a new project, you name the project, and you fill out some characteristics about who owns the projects and etc. And then you begin. first with attributes, and you simply start adding them fast. Right? Then we're doing this for, I think this is for Chrome Web Store perhaps. No, this is, I think this is Google+. Fast, it's simple, it's polished, it's private, it's secure, and you enter all of those things. Click, 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 click. This is easy stuff. Then you go to the components. Components, there's a login component. There's a viewer component. There's a publisher component. Yeah, this is definitely Google+. And now you're finished with those, and you're presented with a grid. The attributes are across the top, and the components are the rows. And now you're going to do the capabilities. So for the capabilities, you click on an attribute component pair. So if you want to write the capabilities for the login component and the secure attribute, you click on that entry, and you start entering them. Login is secure. That's the first, that's the attribute component pair, and you type in the capability. And then you go to the next capability, etc. And so hide the password characters from the user. That is an action. That is a verb. That is a capability of the system. And then you score it. And at Google, we try. See, the idea here is you're going to get a big list of capabilities. You don't want to have to, you may or may not be able to test them all, so you want to figure out what order do I need to test them in, which are more important. And so we rate the importance of these capabilities on a scale, a two-part scale. Right? What is the impact of a failure, and what is the frequency of the failure? How often do you expect it to fail, and how devastating might that be? And there's far more information about this in the book. So you rate all of these things. Now we've got two capabilities for the login secure pair. And once we enter them all, we end up with a grid that looks like this. The red squares are high risk and lots of things to test. The yellow squares are less, right? It goes from red to orange to yellow, and then if there's blank, that means there's nothing to test for that particular attribute component pair. And so we end up with a grid. Now this is an important grid because we can take a look at this and begin to make decisions about how we are going to take testing and divide it into pieces. It may be that we have our test engineers, our full-time employees, test all the red squares. We might trust the orange squares with contractors. We might take the yellow squares and crowdsource them. As we get data back from the field, as we get data back from dog fooders, we can say, okay, we've got all this testing that's going on this red square, and we haven't seen any failures, so it's really not red after all. There's a lot of risk there, but we've mitigated it. So not only can we track the testing that's going on, we can categorize it and say, okay, we are testing these components. As test cases come in, as bug reports come in, we know what components we're testing, what capabilities we're testing. We can map all of this back to risk. Now, that tool has been open source and is available. And so that is a test planning tool, though. The next tool I want to show you is an actual testing tool. This is our record and playback tool that I referred to earlier. This is also open source, and it's also available through the Google testing blog or through the open source blog. Now let's say you're testing google.com. Now, in general, what we're doing is we're collecting this information from our dog food users. We have tens of thousands of employees at Google. They're all using our internal products, and we want to be able to collect feedback from them. We want to get test cases from them, which is what this tool does, and we want to get bug reports from them, which is what another tool does, and I'm going to show you in a minute. Now, an actual dog food user wouldn't see that screen with the blue title bar up there. That is our test case recording screen. But if they're testing google.com, this is what's going to happen behind the scenes. As they start clicking around google.com, we record it as a JavaScript test case. And so as they keep clicking, the test case grows larger and larger and larger. Remember, they're not going to see this, only we see this. And we're going to be able to grab this test case and we rerun it anytime we like. Now, we can put it in a mode where instead of actually seeing the JavaScript, we interpret the JavaScript in a human-readable format and insert those human-readable comments into the script itself. The other thing we can do is add validation. So as we get test cases back from the field, we can put validation in them and then make them part of our automated regression suite that we run all the time, every time a new feature is checked in. So we can add validation based on JSON. We can add it based on XPath values. And we do it simply by filling in a form, and that's it. and then the code is written for you automatically. So this is a great way for test engineers who aren't great coders to still create automated test cases. Now, part of this is also that we get a screenshot view of where the user has been for this particular test case. You can also get video recordings, etc. So this is our way of collecting test cases from the field and putting them in our automated regression suite and running them over and over and over again. Now, if the software changes, you can either re-record the script or you can edit it as we're showing you here, and it's pretty easy editing form. You don't have to actually write any code for it. You simply edit the test case in place and you're done. So that was the second tool I showed you. So the first tool was a test planning tool that's been open sourced. Second tool is a test case recording tool, also been open sourced. And this next tool I'm going to show you is a bug filing tool. Now, bug filing is crucial. If you're going to use crowdsourcing, if you're going to use dog fooders, if you're going to use trusted testers, and mind you, I believe fervently that the users are better testers than your testers. I don't care how good you are. I don't care how many exploratory testing books you've read. I've even written one, and I'm saying that. You are not going to be as good a tester as your users. Your users have the real environment, not one that you've made up. They have real user data, not stuff that you've created. And they're running real user scenarios, not the user scenarios you've been able to think of and document. You, as a tester, are pretending to be a user. Users aren't pretending. They're being users. Now, what if we could turn those users into testers? And now, the tool I just showed you, we've done part of that. A user will use the software, and we get back test cases. This part of it is the user will use the software, and we get back bug reports. Now, if you think of something like Google Maps, which is another product that I owned for some period of time as a test director at Google, how are you going to test this? I mean, seriously, this is a testing problem of literally planetary proportions. The only person capable of knowing that there's a bug on my address or on my street are the people that live at that address or the people that live on that street. No one else is going to be able to identify that bug. And this is really difficult to do. We're Google. We're a fairly wealthy company. We can't hire enough testers to test Google Maps. We have to rely on dog fooders and users to help us. We absolutely have to. And it turns out it's a good thing anyhow because they're better than us. So let me show you how the bug filing process works. Now, this is a tool that is not yet in open source. It's close. Parts of it are in open source, but it does have connections into our back end because literally users are submitting bug reports directly to our bug database within the walls of Google. So in this case, what you're seeing is the internal dog food version of this tool that every Google employee has pushed to their desktop and are using. So here's how the tool works. Here's the bug reporting process. So let's say you do a search for Seattle pizza and you get these results. And you click on one of them and you notice there's something wrong, right? Maybe the name is spelled wrong or there's something wrong with it. If you want to report a bug, you go and you click on this little icon at the top. Now, there is an experience that you can see based on Google feedback for the maps that we publicly do. I want to just remind you again, this is an internal bug reporting experience that only Google employees are seeing at this point. So you click on this, and you say you want to report a bug, and it says, okay, what type of bug? And this is, again, this is customized just for Google Maps. You click on what type of bug, and then you point at the part of the screen where the bug is, and you just click, and that's it. And now you go to the bug reporting screen, and you can include screenshots, you can include video recordings, and under the scenes what you don't see is that we're collecting stack traces and we're collecting DOM dumps. You notice we're not asking the user what version of the browser are you using and what operating system are you working on. We don't have to ask any of these things because the tool itself is collecting all this information. It's collecting everything that the developer is going to need to reproduce this particular bug and debug it and fix it. So all that information is collected invisibly, and you click next, and now you're done, right? This is the screenshot that's going to go to the developer. You get a chance to see it, but you're done. That's 4 clicks and the bug has been reported. If you're going to involve dog fooders and crowdsourcers and users, you need a tool like this to really make your job easy. Otherwise, you're going to get bug reports that you're going to have to do a little more triage work on. And so this is the one that we use internally. And now, what does the developer see? So let's take a look at the developer experience here. Whoops, sorry. I went past that. I don't have the developer experience slides in here. Those are the ones that I must have dropped off. Okay, good, because we're running out of time anyhow. So I've got one final tool that I want to talk to you about. Oh yeah, here they are, bug bite visualization. So this is now the developer experience. So the user has found the bug, they've reported the bug, and this is the experience that the developer gets. So the developer can fire up Google Maps, and they can say, I want to see the bugs. They click on the same exact icon as the user did, and they say, I want to see my bugs. And we show them all the bugs that are on the current map tiles that are displayed in their window. These are all the open bugs. We scrape these from the actual bug database, right? We're not creating a new bug database. This is a bug database that the whole Maps teams use, that all of Google web application developers use. We scrape the bugs and we show them. They can click on one, and we say, okay, these are all the open bugs that you need to fix. So this developer said, I want to fix a bug. Where's the ones that haven't been fixed yet? And so we overlay red on top of the maps so that they can see the bugs that need to be fixed. And they can click on one of these, and they get information about it, and they can go off and do their debugging. And once they fix it, it turns yellow. And so now one of our testers will automatically, this all hits our automated workflow system. The tester will see that a bug has been fixed. They can click a link in that. They'll go right to this page. They'll see the yellow overlay. They can read about the bug, and then they can verify, okay, this bug has actually been fixed. And once they click resolve, it will turn green, and then eventually it will completely drop off. So that's the bug reporting and the bug fixing experience. I've got 3 minutes left, just enough time to talk about one final tool, which we call quality bots. When I first took over testing of Chrome, we were doing lots of things manually that didn't make sense to me. Every time we revved Chrome, the question was, have we broken the internet? Can this new version of Chrome still crawl the major pages and still render the top 100, the top whatever sites properly? The last thing you want to do is build a browser that won't load CNN, or build a browser that won't load Facebook, or build a browser that won't load some really popular application on the web. And so we decided to figure out how to do what we could do automatically. Now, it's easy to take the top 100 sites, load them, and check for a crash, right? That's a simple thing to do, but it's not particularly useful, and when we wrote that tool, it didn't find many bugs. What we'd really like to do is we'd really like to go through the top 100 or the top 10,000. It's actually 10,000 now that we do this with. The top 10,000 sites, render the page, and make sure that that rendered page looks the same as it did in the last version of Chrome, or looks the same as it did with Internet Explorer, or looks the same as it does with Firefox or Safari. That's what we'd really like to do. And that's the tool that we built here. So you can enter URLs into what we call quality bots. By the way, this is also open sourced on the Google testing blog. And the bot will remember every URL that you want to crawl with the latest version of Chrome. And it will compare that to, so this, I hope you can see this okay. This is the canary build, the dev build, and the stable build of Chrome that it's going to compare it to. So for each of these 10,000 URLs, it has stored results for the stable build, stored results for the developer build, and it's going to go through, crawl all 10,000 of these sites and create results for each of those top 10,000 sites and compare it to the stable build and compare it to the dev build and make sure that they're equivalent. So it goes through. You can enter more URLs if you want, does all of its crawls, and then it gives you its results. Now, what it does is two things here. First of all, it compares the DOM. Does the DOM after you render CNN.com look the same on the stable build, the dev build, and this current Canary build? And if it's close, we say it passes. If it's not close, I'll talk about it in a minute. So we go through all 10,000 of those, and most of them are close, right? We're not making major change, so many major changes in Chrome that it breaks, but there are some minor things that can be wrong. So now, if the I talked about the DOM. The second thing we look for is the placement and properties of all the controls on the screen. So if the DOM looks good and the placement of all the controls look good, we check it off and say CNN.com is fine. If one of those two are a little bit off, because they always are off, right? CNN.com serves ads, and the ads look different. They're going to, if you run a comparison today as opposed to tomorrow, as opposed to the next day, you're going to get differences because those ads are differences. You're also going to get differences because of bugs. So what we've got is a little threshold in there based on our experience that says, okay, it's different, but it's not different enough to make us think it's a bug. If we do think it might be a bug, we farm it off to some crowdsourcers at utest.com, and those guys look at it. Right? A human being takes a look at this, because this is a really difficult thing to do for a machine, to look at two web pages and say, yes, this is right, or yes, this is wrong. It's really easy to do for a human, and this is what the human sees. The human sees the two web pages side by side, and they're asked to click yes or no. Is this the same or is this not the same? We make it easy for them by showing them the actual differences in the two screens, and they can look at it and say, okay, this looks fine, this is not a bug. If it is a bug, it goes back to the developer, and the developer can get even more information by looking at the underlying HTML and structure of the DOM to see if it really is a bug. And so this is a combination of automation, where automation makes sense, and human judgment where that makes sense. And so apparently Q&A is now in session. I went 1 minute over. I hope you got something out of this. I realize in advance that 45 minutes of a 4-hour tutorial is very difficult to create a long and continuous story from. I tried my best to hit the highlights. I tried my best to hit some of the tools that feedback has told us are the most popular. I hope I did a good enough job of that. And I believe I'm passing it back to Francesca now, who will open up the Q&A session.
That's correct, James, and I won't penalize you for going over. That's quite all right. Now, before we start Q&A, I just want to remind the audience you can ask James questions by typing it in the window on the left-hand side of your console, and then clicking the Submit button. In a minute, a short survey is going to appear in your console. If you would, take a moment to complete it. Your responses are going to help us develop our web seminar programs to best fit your needs and give us valuable feedback as well. So with that, we've got so many questions in queue. I'm just going to jump right in and ask you the first question. James, you ready?
I'm ready.
All right. How do you deal with bugs that are not really bugs? For example, are duplicates, invalid, etc. You probably get thousands of bugs daily, and they must overlap, be invalid, etc. So how do you manage those?
Okay, so first of all, the things that aren't really bugs, you are doing everyone a disservice by reporting those in the first place. One of the first things I did when I took over a test of a couple of products at Google was go through and find out who was submitting these things that aren't really bugs. These people are out of step with the project. They don't understand tolerances. They don't understand what's important and what's not important, because sometimes a bug isn't important and won't be important for another 6 months. You need a different way of dealing with that than to randomize some developer, because it takes a lot of time to diagnose these bugs. Bug duplicates, you got to get rid of them. Now, on that Maps project that you saw, the bug reporting mechanism there, you can't report a duplicate. It's impossible. Because as soon as you try, the automation underneath says, oh, I've already got a bug reported against this. It's a duplicate, and it doesn't bother, right? So the users will actually see each other's bugs overlaid on that screen. You've got to get rid of these things. Now, if you just have developers who just don't want to fix bugs, now that is a different and more difficult situation. The culture at Google has mostly been that we have been able to retrain our developers to not think that way, that we've been able to reward bug fixing and the time it takes to do that, etc. And happily that's in the book, so you'll be able to read sections on basically how to manage your developers from a psychological point of view. Let's take another one.
Sure. How much time do you spend on maintenance for these record playback scripts?
Hardly any. So we will either throw away the scripts that are hard to maintain, just ignore them, right? You can always re-record them. We're constantly getting more scripts that are coming in from our dog fooders and our trusted testers. So if a script is causing a problem, then it's not a bug in the application, throw the script away or re-record it. Maintenance is no fun, and it's not valuable. Next.
Okay. The more traditional developer and tester roles seem to be blurring. Do you have any suggestions for how a non-technical tester can begin to gain these new skills?
They most certainly are blurring. In fact, I think many of the SETs at Google will be migrating into SWE roles. I see testing as a very development-oriented problem, right? All small and medium tests really are written by people who can code, people who can code at the level of a feature developer. And so I do think that a lot of that technical testing is being absorbed into development, and I think that's a good thing. I think that's where it belongs. The tools like our record playback system, I mean, we had one contractor that started using this and learned JavaScript simply because he was so involved in recording it and manipulating it. It just became familiar with him. I bought him a JavaScript book out of my own money. He read it over the course of a week. He is now very, very good at JavaScript, and Google hired him as a full-time employee. So don't be afraid to learn it. It's not that hard. And developers like to act like it's hard because they can do it, and a lot of us can't. Don't believe all that crap. It's easy to do. Just learn it.
Okay. How did you get the developers to write automated tests?
We didn't give them a choice. So in How Google Tests Software, Pat Copeland wrote, he's the guy that started all this at Google in 2006. He wrote a very long preface on the state of Google at the beginning of when he first came, where testing really was a second-class citizen and developers refused to take part in it. And it was a 1 to 2 to 3 year turnaround, depending on how hard you want to judge us on getting that to happen. And so I don't want to steal too much of his thunder from the book because I'd like you to read it from his words and not mine. But basically he did a couple of things that are really important. Number one is he hired people in test who were developers, and that helped get the discipline taken more seriously. And the second thing he did is he decided not to concentrate on test, but to concentrate on the acceleration of development, and that's why he called his department Engineering Productivity. So that's probably the top two. There's more in there as well, but it is a time-consuming process, and maybe every company isn't capable of executing it. I don't know, but Google did, and we documented it in the book.
Okay. What's the headcount ratio between SWEs and SETs, Ts?
So it varies from project to project. I can't speak on behalf of all of Google, but I can speak on behalf of some of my products. Really hard technical stuff, sometimes it's 8 or 9 to 1, 8 or 9 SWEs to an SET. Others, it depends on the person, right? I've got this one Jedi SET, Jordana Cord, who reports to me. She was the lone tester on a project with 28 developers, and she actually had enough time to write features as well as do testing. So it all depends on how well it's organized, who's doing it, how good they are at it, and how well they have their developers trained. And if there's one person on this planet that knows how to train developers, it's Jordana.
Nice. And really quick, if you don't mind, explain what those acronyms stand for some of the people that may have missed it.
SWE is Software Engineer, SET is Software Engineer and Test, and TE is Test Engineer.
All right, thanks. Okay, so what kind of metrics are you producing? Project-based, cost per function point, and how do these break down to numbers and return on investment?
Numbers. Look, there's one number that's more important than anything else, right? And it's not even a number, it's a sentiment. Do people love your software, right? That's the ultimate metric that you can possibly try to measure. Are there large numbers of people? Count them, right? Who are anticipating the next version of your app. These are the sorts of things that you want to do. But you can count stuff, right? You can count bugs coming back from the field. That's not good, right? So think of all the things that are not good, count them. Think of all the things that are good, count them. But don't take those numbers too seriously. If you don't have a large user group out there that's really anticipating what you're doing and really loving your software, that's the bottom line. I really think that Steve Jobs was right. Science is overrated in software development, and the humanities is underrated. Next question.
Poignant. Normally, how much percentage of bugs have not been found by your test procedure and creep into the delivery version or final product, or predication? I'm assuming that this person meant to write final product.
Yeah, right. I understand the question. So bugs. So here's the thing. This is something that you definitely do not want to count. I think that you've got to get to a point in your own head that you realize you are going to ship bugs, period. It's not about not shipping bugs. Get that out of your head. You will ship bugs. Everybody ships bugs. All software is broken, period. The important thing isn't keeping bugs out of the ecosystem. The important thing is finding them and fixing them fast. Right now I'm a development director in Google+, and my claim to fame in this project is that the bugs that I do ship last only a matter of hours. And once one user sees it and it gets reported back automatically, that's the most important thing on my team's agenda, is to fix that bug. Not write new features, but to fix that bug. And I judge them on that metric. How many hours, and it better be less than 10, how many hours did the bugs that we write stay live in the field? How many users were bitten by that bug? If you want a metric, that's something to count.
Where do you do performance testing? Say in production?
No, we don't do performance testing in production because you slow down production. As soon as you start adding code to find out how fast your code is working, you've got slower code. I'll tell you how I do performance testing. I hired the best performance tester on the planet, Tony Vellum. He's the perfguy.blogspot.com, and he knows everything there is to know about performance testing. And if you wanted to learn more about performance testing, you shouldn't ask me. You should invite him to do a webinar in this series.
Awesome. Okay, so here's a two-part question. And the first part is, are documents still needed in an agile test environment? And the second part is, for testing APIs and or frameworks, how much knowledge of the code implementation should the test engineer have?
Okay, so documents, please don't there's only one artifact that's important, and that is the source code. There's only one artifact that will become the product. There's only one artifact that is managed by program managers, project managers, and developers. That is the source code. There's only one artifact that the users will actually fall in love with, and that is the product, which comes from the source code. Source code rules them all. If there's a document and it's not part of the source code, question whether it's necessary or not. One of the reasons we did ACC is that we didn't want to create documents. We wanted to just create knowledge. The value of testing is not in the artifacts that you generate, but it's in the activities that you perform. The value of testing is in the activity, not in the artifact. Minimize the number of artifacts that you develop. There was a second part to that question, Francesca. Can you remind me what it was?
Sure. Really quick, let me go back to that screen and find it. My apologies here.
Or you could go on to another one.
Well, hold on. Here we go. The second part read, for testing APIs and or frameworks, how much knowledge of the code implementation should the test engineer have?
Oh, yes, I remember now. Testing APIs and frameworks, lots, right? This is where small and medium tests rule. The only large test that really is applicable to a set of APIs is an application that implements something on top of those APIs. Right? So whenever you're testing applications and frameworks, you're always programming. Large tests are you're actually writing an application on top of the APIs, using the APIs. Small and medium tests are you're manipulating the APIs in lower level ways, and that's fundamentally some place where you have to have your fingers deep into the code.
What software development methodologies are used at Google?
None that we have names for. I think as soon as you name something Agile and start saying this is how we implement Agile, you've created a process around Agile, and anything that has a process around it ain't Agile anymore. So it's kind of like, certain religions that won't name the devil. We don't name our processes. They're very Agile-like. They have very Agile-like properties. They certainly happen really quickly, but they're all homegrown, all modified stuff that we get from the field. Very little stuff that's published in the industry comes into Google without getting modified in some way. So it's very agile-like stuff that we don't have a name for.
Nice. Now you referred a few times to that, or you referred a few times that it's in the book. So which book are you talking about?
How Google Tests Software. Maybe you can buy it on Amazon, pre-ordered on Amazon already, but it's called How Google Tests Software. It's by myself, Jason Arbon, and Jeff Carolla. Jason Arbon, who is a test engineer, and Jeff Carolla, who is a SET, who has converted to SWE. And Addison Wesley is a publisher, and I think maybe there's a link for Amazon. You can always go to howgoogletestsoftware.com and wait for an announcement there.
Okay, so now we've reached the top
By the way,
of the
thank you for that promotion spot.
Of course.
Jessica. Oh, yeah.
Well, I'm going to ask for more promotions here. So you talked about where we could find more about your book and whatnot, but what about the blogs that you mentioned before, and also the presentation that you gave at conferences, How Google Tests Software? Do you plan on presenting this again, and where should you steer people? Where should they go to find more information about what you're going to be doing in the future?
Well, they can most certainly follow my blog. It's Google Testing, all one word, .blogspot.com. You can follow me on Twitter or Google+. My handle is DocJamesW. And on Twitter, I always announce where I'm going to be speaking and what I'm going to be doing. So that's a great place to follow my comings and goings and hear my opinions. And then, both Star and Eurostar. So you can go to sqe.com and take a look at recordings of my tutorials and my lectures. And there's also, if you search for my name on YouTube, there's lots of recorded stuff that I've done in the past, some of which I'm not so proud of.
I'm sure it's all good. Well, thank you so much for this wonderful presentation, James.
I really enjoyed it, and I hope you all did too. Thank you.
Well, that ends our event for today. Again, thank you, James, for this presentation, and a special thank you to IBM for sponsoring this event, and a thank you to you, the audience, for spending the last hour with us. Have a wonderful day. We hope to see you at a future event.